Hey, this is Unit 2 Notes, Graphing Absolute Value Functions. So on the previous notes, we talked about the absolute value parent function, and that equation is y equals the absolute value of x. We also talked about the key features of this parent function, such that the x and y intercepts were both at the origin at 0, 0, and the axis of symmetry is at x equals 0. We also completed the table yesterday by taking the absolute value of the x values. So the absolute value of -3 is 3. Then we get 2, 1, 0, 1, 2, 3. Again, repeating from last notes. I'm then going to take those points that I got on the table and I'm going to plot them so we have a diagram of our parent function. So I have -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. Okay. So if I connect this, remember yesterday we talked about how the shape of the absolute value functions look like the letter V. And the vertex of those absolute value functions is always at the point. So no matter which way our V is facing, it's always going to be that point of the absolute value function. That is the vertex. Okay, so now looking at transformations, remember yesterday we talked about the vertex form of the absolute value, and that was y is equal to a absolute value x minus h plus k. And the reason it's called the vertex form, if you remember, is because it gives us the vertex h comma k. So when we look at the form here, we have that a value, but now we have an additional value, that b value. And when you see C and D, just think H and K. So each of these components is going to do something different to the graph. So starting off with A, if we whatever value of A, that is going to multiply all the y values by A. So that A there is going to multiply the entire equation by A. If our absolute value of A is greater than 1, we're going to have a vertical stretch by A. If our absolute value is less than 1, we're going to have a vertical compression by A. Pay attention here where it says the absolute value of A is less than 1. Remember, the absolute value can only be positive, so it's not talking about negative numbers. It's not talking about just any number smaller than 1. Specifically, it's talking about fractions. So when you see this, this is fractions. So if our A value was a fraction smaller than 1, then we know we would have a vertical compression. Okay? If it is a whole number greater than 1, then we are having a vertical stretch. If A is negative, then we are going to have a reflection over the x-axis. And we talked about that a little yesterday where we said, okay, if A was positive, it looks like the V, but if A is negative, it looks like the V upside down. Okay, so it flipped over the x-axis. Now, let's see what B does to our function. So B, you're going to take that value and it's going to multiply all the x values by 1 over B. Okay, so it's taking whatever B is and it's flipping it into a fraction. So if our B value was, for example, 3, that's the same as writing 3 over 1, and we could flip it to become 1/3. That's what this part means, just to flip. Okay. If our B value, our absolute value of the B value is greater than 1, then we are going to have a horizontal compression by 1 over B. If the absolute value of B is less than 1, we're going to have a horizontal stretch by 1 over B. And if B is negative, then we are going to have a reflection, but this time over the y-axis. Okay, now let's see how C affects our graph. So for C, you are either going to add or subtract all the x values by C, depending on if C is positive or negative. So if C is positive, it's greater than 0, then that is going to translate the function right by C. If it is less than 0, it's negative, then it's going to translate to the left by C. And then lastly, D. This D value is going to add or subtract all the y values by the value D. So add or subtract depending on whether D is positive or negative. We will have a translation up by D if D is positive. It's greater than 0. If D is less than 0, then we'll have a translation down by the value D. So think of this here as your little cheat sheet. Okay, this is going to have all the rules and properties when transforming absolute value functions. So this would be very important to study before the quiz. Okay, so looking at example 1, it wants us to look at this transformation and label everything that happened. So we're labeling our A, B, C, and D. So that's what I'm going to do first. So I'm going to label my A, B, C, and D. And if you remember from above, that format was plus or minus A, absolute value of B, parentheses, X minus C, plus D. Okay? So looking at each part, we can see that our A value is -1. It's that negative right in front of the absolute value. Our B value is 3 because it's a number outside of the parentheses. Our C value is -1. So remember yesterday when we were talking about the H value, we said whatever number you think this is, pick the opposite. Because in our formula, we already have a negative. So it's going to be the opposite value. So this looks like it's going to be +1, but actually it's opposite, which is -1. And then our D value, which is -2. Okay. So that A value of -1 is going to reflect over the x-axis. The 3 is going to be a horizontal compression by 1/3. Remember that 1 over B. Since we have a -1, we are going to go left 1. And since we have a -2, we're going to go down 2. Okay, so that's what we're doing for 1, 2, and 3. We're listing the transformations that are happening. So on number 2, we are going to again label our A, B, C, and D. Notice that there's nothing there for our A value. But we can't just write 0, okay? Because 0 times anything with 0, which means this wouldn't even exist, okay? So if we don't see a value here, then we have to remember the imaginary 1. So there is a 1 there. It's just invisible, okay? So our A value is 1. Our B value is 1/2 because it's outside the parentheses. Our C value is going to be opposite, so instead of +4, -4. And our D value is 1. So that a value that was equal to 1, it didn't do anything to our function, because if we go back up to our note section, we are looking at to see if a is greater than 1, if a is less than 1, or if a is negative. Since it doesn't hit either of that criteria, this does nothing. Okay, it does nothing to the function. The 1/2, however, since it is less than 1, we are going to have a horizontal stretch by 2. Okay, remember, it's 1 over b. Okay, what that 1 over b means, we flip the fraction. So since we have 1/2, if we flip that, we would get 2. Okay, c equals -4 tells us we're going to the left 4, and d equal to 1 means we're going up 1. Okay, now let's look at number 3. So number 3 is a little off, okay, because remember, if we look at that formation, we have plus or minus a, absolute value of b, parentheses x minus c, plus d. Okay, inside those brackets or parentheses, we should just have x, not negative x. So this tells me that I have a b value. However, I can't just write that my b value is -1 and my c value is -5 because I'm missing these parentheses here. So we have to remember back to Algebra 1, and before we start this, we are going to have to factor out that negative, so we have that negative outside of parentheses. Okay, so if I factor out a -1, negative x divided by -1 is x, and 5 divided by -1 is -5. So now I can rewrite my problem, and now I'm able to label my A, B, C, and D. Okay, so I wasn't able to start from the beginning because I did not have parentheses in there showing me that my B value is -1. So my A value is 3, B is -1, C is opposite, so +5, and D is -1. That 3 is going to give a vertical stretch by 3. The negative is going to do a reflection over the y-axis. That +5 is telling us we're going to the right 5, and that -1 is telling us we're going down 1. Okay, so 1 through 3, we took our function and we labeled the transformations. Now they are going to label the transformations, but we're going to have to rewrite the new equation. So we're starting off with our parent function, f of x equals absolute value of x. And then it says it's being translated down 3, then reflected over the x-axis, and then horizontal compression by 1/3. So 3 things are happening here. Okay, so remember, if we write that plus minus a, absolute value b, parentheses x minus c, plus d, okay, we need to alter this and figure out what each of these are. So down 3 is our d, okay? Reflection over the x-axis is our a. Horizontal compression by 1/3 is our b. Okay, so if I'm filling all this in, I have f of x is equal to, we said a, reflection across the x-axis, that means I have a negative. Absolute value, we have our b, which is our horizontal compression of 1/3, but remember, we put 1 over b, so I need to flip that fraction and it becomes 3. Okay. Then I have no C value. So instead of saying x minus 0, I could just say x and then plus D. So here it's going down 3, so I'm going to go minus 3. Okay. Now looking at number 5, notice that now I do not have a parent function. Instead, I'm starting at a different function. Okay. So first, I'm going to identify all of my translations. So I have 2 units to the right, I have 4 units up, and I have reflection over the y-axis. So those are the 3 things that are happening. So first, it's getting shifted 2 to the right. Okay, 2 to the right. So that means I need to add 2 to my C value. Okay. 4 up means I'm going to add 4 to my D value, and reflect over the y-axis means that my B value is negative. Okay, so starting with the first one, I have f of x is equal to 2x plus 3 minus 1. My C value is negative 3. So I need to add 2 to that, and that gives me negative 1. So now I have f of x is equal to 2x minus 1 minus 1. Okay. Now I need to move 4 units up. So I'm going to take this and add 4. So now I have f of x is equal to 2 absolute value x minus 1 plus 3. And then last thing I need to do is reflect over the y-axis, which means my b value is negative 1. So I'm just putting a negative 1 in front of here and putting some parentheses around what I already have. So my answer is f of x is equal to 2, absolute value, negative, parenthesis x minus 1 plus 3. Okay, now let's look at number 6. Number 6 says, describe the transformation from the parent function and then graph the new one. So first we are labeling our A, B, C, and D. So A is 3, B, there's no B. C, opposite, so negative 1, and D is negative 2. So based on that, now I'm writing what is happening with each one. Since my A is 3, I'm going to have a vertical stretch by 3. Nothing happened with the B, so I skipped that one. And then C is negative 1, which means I'm going to go left 1. And D is negative 2, so I'm going to go down 2. So in order to see this on our graph, I need to start with my parent function. So this is on the front page. I'm just copying down exactly what it says. And then, since I had a vertical stretch by 3, if we look back at our little note section, that tells me that I'm going to have to multiply my y's by 3, so 3y. Okay. So that means my x's do not change, so I'm going to rewrite my x's exactly how they are. But for my y's, I'm now multiplying it by 3, so I have 9, 6, 3, 0, 3, 6, 9. Again, I took these old y values, multiplied them by 3, and got my new y values. Okay. Then it says I am going to go left 1. Left 1, if we go back to our notes, means we are going to take our x value and we are going to subtract 1. Okay. So I'm looking back at my x's right here because this is my new table going to my newest table. and I'm subtracting 1. Okay, so I have -4, -3, -2, -1, 0, 1, 2. And then to find my new y's, I have to look at this part where it says down 2. So that means I'm going to take my y values and I'm going to subtract 2. Okay, so again, I'm taking these y values, subtracting 2 to get my new y values. Okay, so I have 7, 4, 1, -2, 1, 4, 7. What I just created here was my new points that I'm going to plot. So I'm going to go ahead and plot these points. -4, 7. -3, 4. -2, 1. -1, -2. 0, 1. 1, 4. And 2, 7. So if I connect this, this is the function that I just created with all those transformations. Notice it went left 1, it went down 2, and it had a vertical stretch, which means it got skinnier by 3. So filling out these attributes at the bottom, we know that domain never changes, so that's -infinity to infinity. Our vertex is at the point right here of our V, which is -1, -2. Our range, since it's opening up, we are going to borrow the y value from our vertex. So it's going to be bracket -2 to infinity. That's because it's going up. And then for our AOS, our axis of symmetry, we're going to borrow the x value from our vertex, and we're going to write x equals -1. Okay. For example 7, I wanted you guys to try this on your own. So if you haven't already, pause the video, try it on your own, and then push play to see if you did it correct. So in number 7, we're doing the same thing. We are first looking at this function and labeling our A, B, C, and D. So our A value is -1. Our B and C value we can't get just yet, but our D value is 3. Okay. Remember, when we look back, this is plus or minus A, absolute value B, parentheses x minus C, plus D. Okay? We are missing some parentheses there. So if we took our function, this 2x minus 4, we need to see what the GCF is that we can factor out. So again, we're jumping back to Algebra 1. Remember, greatest common factor, GCF. Well, between these two, the number that they have in common is 2. So I'm going to take out a 2 and then divide. 2x divided by 2 is x. -4 divided by 2 is -2. So that means instead of this 2x minus 4 in my brackets, I actually have 2 parentheses x minus 2. So I could rewrite this so I have it. So f of x is equal to negative absolute value 2 x minus 2 plus 3. Okay. So now if I'm looking at this, I can continue and I can say, okay, my B value is 2. I can see that here. And my C value is opposite, so it's also going to be 2. Okay. From here, I'm able to see that because of this A being -1, that I am going to reflect across the x-axis. Okay. For B equal to 2, I am going to, so B equal to 2, so that means it's greater than 1, so I'm going to have a horizontal compression at 1/2. Okay, so that's my B value. My C value is 2. So that tells me that I am going to go right 2. And then my D value is 3, which means I'm going to go up 3. Okay. Once I do all that, that is going to tell me how I'm going to alter my parent function. So remember, my parent function is that -3, -2, -1, 0, 1, 2, 3, 3, 2, 1, 0, 1, 2, 3. Okay, that's our parent function. It didn't change. What we're going to do now is we are going to find... Okay, let me backtrack. Okay, here we are going to figure out how the reflection across the x-axis and the horizontal compression at 1/2 is affecting our x and y values. So the horizontal compression means we are going to multiply that by x. So our x value is going to get multiplied by 1/2. Our y value is going to be multiplied by -1 for the reflection across the x-axis. So -1x, okay? And then once we do that part, we are going to add 4 to x, okay? Because we are going, add 4. No, we are adding 2. That is my bad. We are adding 2 to x because we went right 2. And then we are going to add 3 to y because we are going up 3. Let me highlight everything so you can go back and see where it's coming from. Okay. So first thing I'm going to do is I'm going to look at my parent function table and I'm going to multiply all of my x's by 1/2. So -3 halves, -2 halves, which is -1, -1/2, 0, 1/2, 1, 3 halves. And then I am going to multiply my y values by -1. Okay, so I have -3, -2, -1, 0, -1, -2, -3. Okay, now looking at this new table I created, I'm going to do this next thing by adding 2 to x and 3 to y. So adding 2 to x, -3.5 is the same as -1.5. Adding 2 is 1/2. -1 plus 2 is 1. -1/2 plus 2 is 3 halves. 0 plus 2 is 2. 1/2 plus 2, 1/2 plus 2 is 2.5. 1 plus 2 is 3. 1.5, 3.5. This right here. I meant to write 3.5 and I wrote 3 halves, so it's supposed to be 3.5. And let me go ahead and just change this 1/2 to a decimal so we're staying consistent. Okay. And then for the y's, I'm going to add 3. So I get 0, 1, 2, 3, 2, 1, 0. Okay. Then I'm going to plot these new points that I just found, and I'm going to plot them over here. Okay, so I have 0.5, 0. Then I have 1, 1. Then I have 3.5, 2. Then I have 2, 3. Then I have 2.5, 2. 3, 1, 3.5, 0. I feel like this one. Did I mess up here? So this is negative 1/2 plus 2, which is 1.5. 1.5. Yeah, and that would fall more right here. Okay. So if I was to connect this, we would see that it has a horizontal compression. It's reflect across the x-axis, and it moved right 2 and up 3. So our domain, which never changes, is negative infinity to infinity. Our vertex is at 2, 3. Since it's going down, we are going to borrow this 3 here, but instead we're going to do negative infinity to 3. And then for the axis of symmetry, we are borrowing the x value, and we get x equals 2. Okay, so this is what you should have got for number 7. Go back, double check your work, and that's it.